Okay. So you just have to give us a signal when we're supposed to start, right?
Yeah, as I mentioned in my email, just a short welcome, and then it will be hand over to you, Heinrich.
Okay.
It's 7:30. Shall I start, sir?
Please go ahead.
Honorable dignitaries and fellow members of the IEEE fraternity, a very good evening to one and all. Welcome to the final day of IEEE RAICS 2020, an international conference on recent advances in intelligent computational systems organized by the IEEE Kerala Section. We hope that this event, based on the theme Computational Technologies for a Healthy Humankind, has engaged, edified, informed, and inspired you so far. And what a better way to end IEEE RAICS 2020 other than a special session on a much relevant topic in today's era, the Internet of Things, or IoT. You've heard of it, but what is it and why is it promising such vast change? Well, imagine everything in our physical world, all seamlessly connected, securely connected, and everything connected. Even then, you're barely close to grasping the potential of IoT. And today, we are presenting you with some of the most brilliant minds in technology, talking about various dimensions to this topic. Without further ado, to welcome you all on this glorious occasion, it is my honor to invite Mr. K. Srinivasan, Chair of Computer Society, IEEE Kerala Section, to give the welcome address.
Hello, good morning, good afternoon, good evening, wherever you are. Okay, my role is just to welcome you all to this power-packed session on IoT and the advances in IoT technologies or Internet of Things technologies and its applications. We are quite fortunate to have the best of Internet of Things today available for us here. And I take this opportunity to welcome Heinrich Stuttgart. Sorry.
Thank you, Srini. And also a warm welcome from my side. It's good afternoon for me, but I understand it's evening or morning for others here on this conference.
It is India time evening. Can I finish welcoming others also and then?
I'm sorry.
Yeah, then I will hand over to you. Yeah, also I will take this opportunity to welcome Venkatesh Prasad, Dejan Majavik, Adam Drabat, and Chandrasekhar and Sri Chandrasekhar, all to this eventful evening where I think the entire IEEE teams in Kerala and India are waiting to hear from you. I also take this opportunity to welcome all IEEE team members here from Kerala section and all IEEE members who are connected here either through Zoom or through YouTube. Over to you, Heinrich Stuttgart.
Thank you, Srini. And also, as I said, a warm welcome from my side. I don't want to take time from the speakers. So what we will try to do is give you a brief, not overview of IoT, but a glimpse of different things that are happening in IoT. There is a lot more, but you know, it's difficult to pack it all in 1.5 hours. So without further ado, I would like to invite Professor Venkat Prasad, his friends call him VP, to start with the first presentation. VP is a professor at the Delft University of Technology in the Netherlands, and actually a graduate from IISc in Bangalore. He has published more than 300 papers in international journals, conferences, etc. And also he is, and this may be interesting for you, he is an advisor to the Indian government on developing cyber capacity of India. So with that, Venkat, please go ahead.
Sir, you mute, sir. Sir, your mic is mute, sir.
Okay. Yeah, now you should be able to hear me.
Yeah, perfect.
Great. Um, I'm going to just present a small piece of work. Given the time, I don't want to push too much into the details of the work that we are doing. I'm still having problems of the infection. So I must also thank one of my EU projects that gives me bread and butter. It's called Insect. If possible, have a look at it. Lots of great work is happening there. Because I'm going to be the first one to present in this session, so I thought let me just give 30 seconds of big picture of IoT. So it is Sense and the City. So I know some of you might get triggered about one of the well-known program, SOAP. Anyway, IoT connects with each and everything that we touch. Something from buildings to transportation, and to universities and industry, and also with respect to, let us say, navigation systems. Now I am also working a bit on space IoT, so there is a lot of interest already in there. So IoT encompasses everything that we actually see and then work or use indeed. You could also see that there are something that is major blocks that you could see in any IoT related applications or systems that you could see. Something that you really see is sensors and actuators and wireless connectivity, smart gateways, maybe cellular, maybe other than cellular connections, the one I'm going to talk about, and of course cloud network also come into picture. So basically there are some of the issues that we majorly look at. One is energy, how energy efficient your systems could be, and of course the communication with respect to reliability, spectrum and various aspects, and also you have to really look at the data. Most of the times it has some noise, and of course the security. So what I am going to see or talk about is only the first two aspects, the energy and the communication reliability. So in that sense, it moved. I'm talking about LoRaWAN. Of course, there are so many protocols being tested these days, and also including the NB-IoT for low power wide area connectivity. So why we should really look at is that we are going to see at least 22 billion IoT devices in the next 5 years. So in that sense, you cannot really have gateways or the base stations for every 300 nodes. So that means we need to do something better. So I don't go too much into details of LoRaWAN. So LoRa is basically a long range wide area network. So the idea is that you use unlicensed bands and use it sort of less than 1%, at least in Europe. This strict rule is there. In the US, there is no strict upper limit, but the idea is that use as low power as possible and use 1% or less than 1% of the duty cycle to transmit the packets. And the modulation scheme is using chirps, so it is much easy to decode. and also with transmissions being having less amount of energy, so that the unlicensed bands can be still utilized, and there can be coexistence of multiple devices. So that is the basic premise. So there are multiple spreading factors, which I don't really go into depths now. The ones are called as SF7, spreading factor 7, that is the minimum spreading factor, up to SF12. Probably you should be able to get more information about them. The problem, one of the important issue is that the MAC layer is basically Aloha-like. So we all know that Aloha maximum throughput is only 18%. So if we really want to use LoRa for IoT, then probably we will have less throughput, and if it is around 18%, I don't think we will be interested in doing it. So, but Aloha-like transmission actually makes our life very simple. So the idea that we wanted to work with is how do we really increase the number of devices that can be serviced by a gateway using LoRa. So what you could also see is that, for example, PCSMA, we all know carrier sensing multiple access with probability P that you want to transmit. You could see that LoRa MAC has less packet reception ratio compared to PCSMA. But we should also remember that a node in a LoRa network is completely blind with respect to others. Of course, I'll come back to the sensing part, but in the simplest case, there is no way that a node will know about other nodes, as well as it receives very less information from the gateway, because the channels should be utilized as efficiently as possible. So because of that, there is no ACK from the gateways. So in that sense, you are actually shooting in the dark. So the next version, that was the initial version of LoRa MAC. Later, they introduced channel activity detection to look at the preamble. So if you use, at least you have to wait for complete one preamble, that is approximately minimum of 2 bytes and usually 4 bytes, so that you observe on the channel, and then if there is some transmission happening, then you can actually defer your transmission. With that, you could increase a bit. So the question is how we can fine-tune, given these constraints, can we fine-tune LoRa so that we can push it towards PCSMA, or even rather NPCSMA if the number of nodes are very high, so that we should be able to increase the throughput. So that was the question that we wanted to try. So in that sense, we wanted to make sure that we do CSMA, so we call it as P-Karma. Karma is well known, so you have to be polite. If you are not polite, the others also will not be polite, so it comes back. But basically the idea is politely scaling the LoRa band. So we wanted to reduce the energy consumption, increase the scalability, and also have it as simple as possible, without ACK, without much of control packets, and of course distributed. Before that, what we tried to do was we wanted to find out how good the CAD is in a LoRa network. So we went to Belgium and Netherlands border, where there are no transmissions almost except the radio stations, for example, FM radios, such things. There are no other transmissions. So we went there and then we tried with all the SFs, and then we found out that there is sort of 96% of the times we are able to detect the preamble. But when you are listening on one SF, you may also be able to receive other transmissions. So you could see that the last one, if you are able to see my mouse, when you are listening on SF7, you will be able to listen or find out or detect other SFs also. So we got this data. We got this data, and then we came back and then said, okay, we are going to do CAD and try to be as polite as possible, and then do the transmission. So you can also call it as a flowchart, a simple one. So if you take a node, it is idle till you get a packet, and once a packet is generated, so you do channel activity detection once, and then if the channel is free, then you go for transmission. If the channel is not free, then wait for some time. The idea is that you wait for some time, so that there is the current transmission is over. So then again try to look into the channel and then try to listen, see if somebody else is already transmitting on the channel, and that's where you have the CAD2 here. And if the channel is free, you transmit. If the channel is not free, you go back to the idle position again. So you basically drop it. With these simple methods, what we tried to do was that we wanted to find out what is the channel occupied versus total time. So CFO is channel occupied and channel free, CFF. So we collected this information, and then we came up with a simple design, and it is collision delay ratio. That's first term that you see, and then what we try to do is that because a node doesn't know any other information from other nodes, so what we try to do is that we try to find out the ratio between the collision delay and the total delays. So the collision delay is that when you collide, how much time the packet has been delayed, and if you are able to transmit, you know that the total time that it was in the system. And of course you can also find out the average delay, the maximum delay, and the minimum delay. So these are the things that we found. If I go back to the previous slide, using the curves, CFO curve here, we are able to design. That's where we actually derived this expression. I'll not go into complete details of this. So
you're down to 1 or 2 minutes.
Yeah. So I'm going to show the results now. And using this, a node can automatically and adaptively tune its the probability P with which it's going to make a decision to transmit. Now if you look at the classic NPCSMA or PCSMA, you see the probability P that has to be 1 by n. If there are n nodes, if they are transmitting the packet generating the packets at equal probability, then 1 by P is equal to 1 by n is the optimum value. So, and that's what we try to achieve here. So I'll not get into the details of the things, but 1 or 2 small results that I should be able to present here. So we tried with 40 and 50 nodes, 40 to 50 nodes practically, and later for the limiting conditions we used the standard NS simulations, and you could see that we are able to increase the packet reception ratio, PRR, almost up to 80%, and that is for 250 nodes. So even if you go up to 3000 nodes, so you're almost like 0.4. The PRRs can be really increased by slightly adapting ourselves. And you can also see that if you adapt the graph here, left bottom graph, you could see that we can even almost double the at PRR of 0.2 compared to a static P karma, you should be able to almost double the number of nodes with adaptive P karma. So, of course, I'm going to share these graphs and these slides. You could also see that the energy consumption is much less with respect to the number of packets that were successfully transmitted, and that's what actually matters. So I will not go into the details of each and every graph here. So let me conclude. The idea is that we can still work in the dark and still manage to do something which is intelligent, so that we can be polite with other nodes and increase the successful packet transmissions. And our algorithm can also be adaptive in the sense that if some number of nodes get into the network or some nodes stop transmitting, we should be able to adjust the p-value, and that's what we have shown. To end with, I will take just 10 seconds. Probably this is a very important thing. I end with this. Maybe before the next speaker takes the screen. Be safe and make sure that you are happy, and happy people will be able to bring lots of nice things to this world. And money doesn't really matter. That we have all seen now because of this pandemic. Thanks a lot.
Thanks a lot, VP, for the nice presentation and interesting topic in IoT communications. But as I said earlier, IoT is not just communications, it includes computing devices, everything.
The last one small thing is that during the discussion, I should be able to tell something much more about this topic, something that we are actually working now. Thank you.
We will have time for questions in the end of the session.
Yeah.
So we'll do it then. Okay, next speaker is Dejan Milojic he's a distinguished technologist at Hewlett Packard Labs. He received his PhD from the University of Kaiserslautern in Germany, and since then has published more than 200 papers, 2 books, and 61 patents. Dejan is an IEEE fellow and an ACM distinguished engineer, and will tell us something about IoT computing. Thank you. Dejan, yours is the floor.
Thank you, Heinrich. Can you all see the screen?
Yes.
Yes.
Yeah.
Okay, so sorry, it's going to the wrong. I just have to share on another screen again. I apologize for this. Okay. Thanks for having me. I will continue on the path of happiness that Venkatesh suggested by talking about actually computing for IoT. This is the work that has been done with many people. I should not be taking credit as a lone person. When I look back at almost 7-8 years, almost any presentation that I have given or some of my colleagues were driven by this type of graph, which really says that the growth of data was dramatically higher than the growth of compute. That's the big issue, and that's really the theme of this presentation. Now, we've been observing why has that happened, and we realize that when we look back a few years ago, everything was built around the structured data located in one location, such as Walmart's database, for example, with 40 petabytes. And then the human interactions was another level that increased the amount of data to 4 petabytes a day. That is all of us using Facebook, Instagram, LinkedIn, etc. And yet another explosion was with IoT devices, which is where really we have all these sensors around the car and not just car, but really everywhere else on the highways, etc. And that drives further video recognition, interactions with humans, etc. So the market, even though Venkatesh says happiness is most important, and I agree, there's still market that drives what is happening. So at HP, we've been trying to address that with unconventional architectures, unconventional programming. And what I'm going to focus here is really these unconventional accelerators. And we're not the only one in the world addressing that. Actually, there's almost this Cambrian explosion. There are so many accelerators. There are some estimates about 60 accelerators around the Silicon Valley and in neighborhood, and only some of them are listed. What we tried to do is focus in our research on inference, training, approximate commuting, and most recently on heterogeneity. And I will talk about how we approach these first three. And just like Venkatesh, I'll only touch on these areas. One accelerator that we focus on was based on neuromorphic computing. There are other approaches such as based on optical commuting. And you will see the paradox that we started with computation, but now we suddenly are trying to use memory for computing, or even communication mechanisms for computing in case of photonics. The memristor-based or memory-based computing is built around memristor, and I won't go into too much detail, but it's really going back to hybrid computing, where you have on input, you have the voltage, and then as output, you have the currency. And we built a few years ago this architecture, but it was not programmable. So what we decided that we need to do is extend it just a little bit. We call it generalize or die. We started with something very efficient, just like, a long time ago, you used to program only with machine instructions. And then we added a little bit of instruction set architecture, a little bit of microarchitecture compiler, and thereby we sacrificed with these instructions a little bit of performance, but we got quite a bit of programmability, ability to use a number of different neural networks. So here's the architecture that we built around it. I don't have time to go into details, but it's basically starting from the original architecture here at the center. We built cores by adding instruction set architecture and then tiles around it. And then multiple tiles comprise the nodes. And thereby what we've done is we actually sacrifice a little bit of the tile area and tile power, but we got substantial amount of programmability. In the big picture, the software is much more complex area. And to address this heterogeneity, one really needs to introduce forms of standards. One of them is ONNX, Open Neural Network Exchange, which enables exchanging different neural networks across these frameworks, but also it's a common choking point for different accelerators at the bottom. We've done all kinds of things in support of this, including things that students normally don't do, such as device drivers, firmware, etc. But I don't have too much time to go into detail. So that was part about the inference. That was the architecture optimized for inference. I'll say just a few words about the training. So the big issue was that while we can accomplish quite a bit of performance for inference, for training, the problem is much more complicated because there are different instructions that you use, and they are built around writing, and writing is almost 10 times slower. So we need to do optimizations for that. As you can see, for MVM operations for read are much smaller. In case of ReRAM, when you do MVM, a matrix vector multiplication. But as you start writing, you are almost 10 times worse. And that's true both for energy and latency. So we need to work around it. And we've accomplished using bit slicing this approach so we can share the most expensive parts, such as analog digital converter. But basically, we had to extend this original architecture with another one that has multiple paths. One is MVM, the other is then transpose, and then updates with outer product, and then read write. And here's this overall ultimate architecture. So summary of this part is that because ReRAM is inherently weight stationary and output stationary, we need to do this bit slicing techniques to do optimizations in order to do additional savings compared to the original one. And then the third part of this talk is built around approximate computing. We realize that even though we've done substantial optimizations in terms of inference and training, it's still in certain occasions quite costly because the neural networks are growing dramatically. So what we've done is we looked at how can we find some use cases where we can sacrifice a little bit of accuracy while achieving quite a bit of power and performance improvements. And if you are, for example, trying to recognize cat, the famous use case, it doesn't matter whether you perfectly understand the whole picture as long as you can say that it is cat. So if you look at the components where the power and area goes most, it's really analog digital converter. I said we're talking here about hybrid computing. And if we can reduce the number of bits we're using, we can achieve dramatic improvements, both in terms of energy and space. And you can see for different networks, LSTM and MLP, by dropping from 8 to 6 or even to 1, you can achieve dramatic reduction. And so, but the question is how we do that, and do we do it universally across all layers, or we do it to individual layers? So what we've done, we've tried to quantize, that is, reduce precision at certain layers, and that's a huge problem because there's so many layers and so many opportunities where you can do different types to quantization. Specifically, what we are interested in is partial sum quantization at the ADC, which is output, at weight quantization, which is equally applicable actually to most accelerators, and then also activation quantization. The first and third are very specific to our accelerator. You can do quantization in different ways. You can drop bits at certain locations. So you can drop it at mantissa, or you can do it universally everywhere. So you can, at the beginning, drop 1 bit, and then at the end, you just multiply by 2. So you don't need to use all bits. Alternative would be to drop bits at both mantissa and exponent. And you can do it at every location of these quadruples, or you can drop at the end. So what I'm trying to say, there are many, many combinations. But what matters is that if you, for example, drop from 16 original bits to 12, you can see that accuracy drops very little, only 0.02%. If you drop to 8, it's even a little bit more dropping, just 0.1%. And it goes all the way when you drop at the 6, but it also depends how, whether it's integer or fraction. So if you drop only 2 on integer and 4 fraction, you can see you can still be in a very good position with dropping substantial number of bits and still retaining accuracy. So the question now is, because there are so many combinations how you can do it, it's almost 10 to the 100th, we need some almost recursive approach how we will accomplish that. And we've used reinforcement learning for that. So we started with pushing these networks through original DNN model, and then combining with the quantized one, and then doing some distance measure and reward subject to where we go. And that way we managed to get quite a bit of performance and power improvements without sacrificing accuracy. And that's described in more detail in a bunch of our papers, all 3. So I came to the summary. I decided to give you back some time. Observations are that heterogeneity is helping us overcome the end of Moore's law. That is, we are able to squeeze more flops and reduce power by very specific applications and optimizations. But heterogeneity is here to stay in the foreseeable future. It almost reminds us of the times when, if you remember, there were so many CPUs, and then over the time there was only Intel, and then AMD and ARM, which implemented the same Intel architecture. So we're at the same point where we have many of these accelerators, and there is some consolidation to take place. What we've done is we started with a very specialized ISAC architecture and made a number of improvements by adding ISA and compiler support for the inference, and then we've done the same thing for the training. And finally, we've done quantization at different levels. In the future work, we're going to focus on exploring heterogeneity, exploring additional sparsity. We'll try to do accelerators for function as a service, and then improving security and trust in partition accelerators. The bottom line is that there is a lot of heterogeneity right now, and we're expecting to see substantial consolidation in this market. So if you have any questions, you can reach me at these pointers. Thank you very much.
Thank you, Dejan. And also thank you for staying exactly on time. And again, we do have time for a few questions in the end. After the perspective on how to deal with the IoT data from the computing point of view, the next presentation comes from Adam Drobot on IoT verticals and fit for purpose computing. Adam is a technologist and manager with over 40 years of experience. He was the past chair of the IEEE IoT initiative and has been active in IEEE for most of his career. Among the many stations of his career, he was a senior VP. He was president of applied research at Telcordia. That's, I think, when we met, Adam. Yep. And you know, he has had many other attempts. And he stressed before this year to mention that he also spent some of his early years in India studying as a young student at the Bishop Cotton School in Shimla, right, Adam?
Yep.
So with that, that's floor is yours.
Okay, thank you. So let me share the screen. Okay, there we go. Oops, I'm at the wrong end of this. My apologies. Okay, so what I'd like to do today is sort of give you a high-level view of IoT and what I call fit-for-purpose computing. And sort of related to the applications that people are looking at in the IoT world. So I'm going to start off with a very brief view of IoT. I think very similar to what some of the other folks have talked about. Move on to the vertical markets that IoT is addressing. And I hope at a very high level, I leave you with the main point for each one of those. On the computing side of things, I think following up on Dejan, where he sort of took a serious look at heterogeneity and its importance, I think there is also a very much an emerging hierarchy in the way we do computing. So I'm going to talk about that. And then I hope I tie it all together where markets, computing, and IoT actually meet. So the first part of this is a view of IoT. We do this for a purpose. I tend to think of it, of IoT, as really representing a control loop where we sense things, we aggregate data from many different sources, we extract information, we relate that to models of various kinds, but eventually we make a decision and we take action. So think of IoT at the heart of it as representing a control loop that has a purpose behind it. If I look at the next, whoops, going in the wrong direction, next part of it, and a point to leave behind. When you look at IoT, it really involves an awful lot of technologies, communications being one of them, computing being one of them, but there are many, many others. And the first one is whatever application you're looking at, you better have the domain knowledge and the know-how of how to apply all of these technologies.
Adam, you're not showing your slides, Adam.
I'm not showing my slides?
No, no. What is just the directory.
Okay, it's showing up on my screen.
Can anybody else see Adam's slides?
No.
No, I fear it is the directory itself.
I think I can see the directory from his Mac, but not his slides.
Most probably, sir, haven't shared the entire screen. Might have shared the particular folder. That may be the reason.
Okay, let's see.
Share the whole screen, Adam. Now we see.
This
Yeah.
is better.
Okay,
Now it's right. Now it's good.
sorry about that, folks. Okay,
You owe me a drink.
I definitely do. Okay, so let's move forward. So I was talking about the technologies, and there are many of them. The point to leave behind is that whenever you approach something the IoT world on the engineering side, you have to have systems thinking, you have to do the trade-offs, and you know, a typical solution will actually address a fairly large fraction of the kind of technologies that we're talking about here. The next point is, if you actually take a large picture of what the IoT world is about, you have vertical specific applications. You typically have platforms in between those and the actual end system implementations. They consist of the common components. This is all the technologies that we use. They have specific services that are a fit to a vertical sector, the kind of attributes that you need, and then lastly, performance. Okay, so I think of this as sort of 4 buckets that you have to keep in mind. Okay, let me turn from that to sort of take a look at the verticals and markets that IoT uses. And quite often we tend to do this quite loosely. If you talk to the economists, there are sort of 3 systems used around the world. In the US, what defines the markets and the activities around them is something called NAICS, the North American Industrial Classification System. It applies to the US, Canada, and Mexico. The Europeans use something called NACE, and then the United Nations covers the rest of the world and uses something called ISIC. Okay, and this tells you something very important about IoT and how it works. It's one of the good points about it, and it's also one of the tough points. So if you look at these classification systems, they're sort of hierarchical. Each sector that you may want to apply IoT to is actually designated by a 2 to 6 number code. I'm just showing you a particular sector, which is manufacturing. So when somebody says manufacturing, I have no idea what it means, because manufacturing is done very, very differently in the different subsectors. So there is stuff around food, there is stuff around surprisingly commodities like wood, paper, petroleum, chemicals, and so on. And then there is the world of machinery. So what you find is what you may have thought of as one sector called manufacturing really ends up being around 15 very, very different kinds of activities at the same time, okay? So if you go on with this, what you find is at a high level, if you look at those two number codes, and I don't care whether it's NAICS, ISIC, or the North American classification systems, they're very similar. There are around 24 major verticals that actually sort of represent the vertical world and the places where IoT is going. Around the world, it's around 17 million different kinds of businesses, okay? So, and if you then start taking a look at each of those, these tend to be from the top places where IoT is being applied, whether it's agriculture, healthcare, construction, smart cities, automotive, education. What you find is this is a tremendously large list, okay? And you will find every single one of these verticals, you could probably identify north of 10 different business cases or use cases that are already implemented, okay? They don't roll up the way large companies like to think about it. So they've spent lots of time, lots of effort. Customers have gone elsewhere. But I can tell you, IoT is being practiced across this whole panorama. So let me then take a look at, how do you then look at what these verticals are calling for, what are they using, and zero in on computing. So if you look at the computing world, the first thing is you have a hierarchy. That hierarchy goes from the largest installations on the planet. These are the high performance computing and hyperscale data center, things that are in the cloud, things that are at the edge, the computing we do that we embed into things, traditional workstations, all of that, all the way down into things, into computing that's done within things, okay? And if you take a sort of broad view of this, what you actually find is the heart of the market was exactly what I think Dejan was describing, and that's general purpose computing. How do you build things that are applicable to as many things as possible? That's a growing area. I can tell you the embedded stuff is growing, and so is the stuff at the high end. So the first thing is you have a hierarchy. The next thing is when you start looking at computing for IoT, a total explosion of all kinds of accelerators, as Dejan said, from CPUs to FPGAs, hybrids, inference engines, tremendous investment in this. And I'd say it's a little bit more than going after the gap in Moore's law. To me, it's a discovery that we're doing much more complex things. They involve a lot more data. They involve manipulation of that data in various ways. And so people are discovering new architectures for how to be able to deal with those, whether it's TPUs that are now all over the place, neural processing units for learning, a lot of new experimentations. So where this all comes together is that to go along with the hierarchy in computing, you also have a hierarchy in the communications that are necessary, because if I have stuff in the cloud, it has to be tied into stuff at the network edge or the compute edge, all the way down to the devices, all the way down to the things at the endpoints, okay? So you have both heterogeneity and you have this hierarchy, and you're trying to ask, where does stuff belong? On top of that, you have very popular right now, the use of AI. There are things that we do that are real time. There I may have an inference engine. It probably runs 6 to 7 orders of magnitude faster than what I may actually do up in the cloud, where I'm doing my learning. And so again, there is sort of an emerging pattern that you have that says, here is the real-time stuff I'm doing, the intermediate stuff where I'm correcting it and gathering data, and then the slow stuff where I'm actually doing my learning. All of this needs computing at different levels, and it also needs communications at different levels. So what's the bottom line from this? When you take a look across all of these verticals, you take a look at these emerging heterogeneity and hierarchy of things that we have, almost every technology, in fact, emerges as having those two properties. It has a hierarchy and it has heterogeneity in it. And I don't care whether it's computing, whether it's storage, whether it's sensors. The point is that the total number of common components from which you build IoT solutions numbers in the millions. The number of core services, if you look across the verticals, because they all do it in a different way, you may have hundreds of thousands, different performance parameters and concerns in each area, again, hundreds of thousands, and the base requirements, surprisingly, again, a very large list of things, okay? So this is a huge space, and the first thing is, in this huge space, a single architecture doesn't solve all the problems. Hopefully, we're zeroing in on a number of dominant architectures that we can count on the fingers of two hands. I don't think we're quite there yet, but that's the progression that you see in IoT. And so when you start looking at markets, you may have stuff that goes in a home. You may have it in agriculture, robots on a line, something sitting on a drone, a hospital robot, chatbots, medical devices. What you will find is this stuff ends up almost everywhere. And so when you start considering what kind of computing do I need where, you find I got to take a look at the environment I'm going to be working in, what the size of things I can put in is, how much do they weigh, how much power do they consume, and how much do they cost. And this is what I think of as fit-for-purpose computing, is to actually do those trade-offs and end up with, I would say, as general architectures as possible that span the space. So with that, I think I'm done and we'll be ready for questions. Okay, thank you.
Thank you, Adam, for a great presentation and giving a broad overview of what IoT is and what it includes, which is a challenge. We'll have the questions at the end of the session. So with that, we can move on to the next speaker, as we have now covered a couple of different areas of IoT. There is one dimension we haven't touched on yet, which is standardization. So our next speaker is Sri Chandrasekaran. Sri has 25 years of experience and is currently a senior director and practice lead of foundational technologies in the IEEE Standards Association, where he deals with standards for IoT, smart cities, sensors, blockchain, etc. Before joining IEEE, Sri was associated with Freescale Semiconductor, managing their global R&D team, focusing on various, mixed signal designs and system level power analysis. Sri, with that, please go ahead. Maybe you're still on mute.
I hope you are able to hear me clearly.
Yes, we can hear you.
No, I'm not on mute. Okay, thank you. All right, so Heiner, can you confirm that you are able to hear me and they can see?
We are able to hear you, but we are not able to see your screen yet. Oh, okay. Now we can see. Yeah, now we can hear you and see the screen.
Okay, sorry about that. Thank you. So I thought I will start the presentation with the standards impact. And what more to talk about standards impact than talk about the Wi-Fi market. And I think VP talked about the number of devices that are going to be connected. If you look at the number of annual shipments of Wi-Fi devices and the cumulative shipments, I think talking about 50 billion devices in 2025 is much more a reality than what some people might think of. You can even reflect upon your own journeys, when you go to the airport, when people are putting devices on the scanners, each of them have about 4 to 5 devices. So you can imagine this is growing. I think the connected devices, working from home has definitely
Sri, your voice has disappeared again.
I keep getting muted. I don't know why, but hopefully this is a second or third. Talking of standards is not easy often. So I try to throw in some picture called the rush hour. And the highlight of this is when I do this interactive session, I do it slightly differently. But the highlight here is whenever I ask people, who are these people, these two actors, typically I get another person. And that talks about the power of the brand, right? Like you can't even see the person's face, but you are able to identify the person. Sorry, it looks like I'm in a very unstable connection here. I apologize for that. I hope people are able to hear me back. So what I was saying here was there are two things. One is Chris Tucker is telling Jackie Chan, do you understand the words coming out of mouth? And I think Dejan referred to it, or more importantly, Adam referred to it. Now there are a lot of devices that are getting connected. The computing is becoming very important, but interoperability is becoming very, very significant. The devices that connect to each other, we are living in a system of systems world. They need to understand each other. They need to talk to each other. So it is extremely important for establishing stable protocols that are able to allow these systems to talk to each other. Within the IEEE, there is a series of programs that we have, and I won't touch upon everything. And when we are living in an extremely complex world, sometimes it is not very obvious what standards needs to be developed. I think Adam talked about the various number of architectures, and that is slowly coming down. So what IEEE Standards Association has created is a program called the Industry Connections Program. And this is a pre-standardization activity where it allows people to come together to understand in a complex system what needs to be defined before we go and define the standards. So it is exploring and incubating new technology and its use. And at the other end, we have something called open source. I think a lot of people in this audience might be already using open source. I think it is a very powerful tool. And open source is technology to standards. Today, a lot of people are implementing these standards in an open source way. It is important to understand that how these communities work together. And there is a platform that IEEE has provided, which allows for open source and standards to coexist. For people who are curious, you can go to opensource.ieee.org. So let me advance my slide. So touching upon connected devices, new verticals, I think it is important not to lose sight of the fact that today there is no vertical that is not getting connected. You know, if you look at some of the times I grew up in, there were some classical industries where there was no IT and OT integration. But today, if you look at it, whether you look at mills, whatever you look at it. So with that view, IEEE is also taking a significant approach in trying to understand we are not just about developing protocols in traditional power and energy areas, but also look at expanding these areas and how we can address connected technologies, whether it is from a pharmaceutical domain or agricultural domain. And of course, Adam mentioned AIS, artificial intelligence systems, which is becoming extremely critical as we speak. So when we talk about IoT, there are different things that people think about. There are different views of it. So before I talk about what different things have in common, typically when people say Internet of Things, you know, it's like a blind man under the elephant, right? Some people might be referring to cyber physical systems. Some people might be in a very narrow scope of machine-to-machine communication. And then we have Industry 4.0 or advanced manufacturing, the connected world. So all these will be defined so that applications can be developed on this. And what do all these things have in common? They have a deep digitization, extremely well-established protocol. But Adam showed a slide where he talked about the closed loop and the full life cycle. So you have a generation of data, gathering, storage, and most importantly, the analysis of data, and hence closing the control loop by design. One key aspect that I wanted to highlight, and this is something that IEEE is focusing on today, is the fact that requirements. IoT system, does it address my privacy concerns? There is a framework that IEEE trust, identity, privacy. Idea is the non-functional requirements are becoming, if not more important, as important as the functional requirements. So what do I mean by that? We talk about all these other aspects of computing. But now when you are actually implementing this system in the real world, people are very, very concerned about these aspects, and IEEE and IEEE Standards Association is extremely focused in these areas where we are developing standards, where people should think about these things when they are developing these products. I won't touch upon this. I think a lot of people talked about where the inputs are coming from. They are coming from almost all domains. Today, if you look at it, you know, you have embedded sensors in your clothing. You have seat warmers on your car. You go buy a movie ticket online. You book a taxi online. So basically, we are looking at device inputs coming in from various aspects. And really, this has really had a massive impact. IoT has had a real impact. We talked about the billions of devices, but the extreme amount of application domains. But more importantly, I just wanted to take a second about the different business approaches, right? The intelligent services, making decisions based on the data that you gather and creating different value chains. And that has resulted in very many different business models. People call it the Uberization. And there are new actors that are coming in. In fact, IoT and machine learning has really spurred the startup ecosystem. There are a lot of new people who are looking at solving problems in a significantly different way. So in all this context, I wanted to touch upon a few standards that are really key that is driving this in the next couple of minutes. IEEE 802, for people who are familiar, the Wi-Fi is known as the IEEE 802.11 and Ethernet as IEEE 802.3. This standard actually started 40 years back. Through the landmine 40th anniversary of IEEE 802 with the first proposal that was made in August 1979. And you can imagine how the life has changed with the way we use Wi-Fi. You know, we are always looking for a Wi-Fi signal wherever we go. And in that context, there are three key areas that 802 is driving. A lot of people would be talking about 5G and millimeter wave, how 802 is making a significant difference. There is an IEEE 802.11 AD on the 60 gigahertz and the millimeter wave. And the next generation Wi-Fi is coming called the IEEE 802.11 AX. And then you have the sub-gigahertz, which is looking at a lot of applications, which is on home automation, industrial automation, agriculture, and so on and so forth. IEEE is developing several significant standards in this area. We talked about the landman. There is an architectural specification we are doing 2413. There is power line communication. Security aspects that which are coming into place. Like we talked about the verticals, the last time is focusing on medical interoperability. How can devices such as a sleeper, I think somebody showed a picture of that, can communicate to a remote Internet of Medical Things, right? So these are all very, very critical items that are coming in. And some of the things are at the architectural level. Some of the standards are looking at how do you define the sensor performance. Sensors is ruling the world today. How do I make sure that when I buy a sensor off the shelf today to an Amazon that I'm getting the same quality of data? So these things needs to be validated, and there are standards that are being developed to validate these things. And underpinning all this, broadband access will continue to play a very, very important role, and that is directly mapping to the UN Sustainable Development Goals. You take any goal today and you will need broadband access, and this connectivity will make an extremely positive difference. IEEE is not alone in this game. There are several actors, in this space. And the idea is to collaborate collaboratively when we are talking about a system of systems, and VP talked about laws, come together when you are building a complete system. I want to conclude by saying that the IEEE Standards Association is really raising the world standards. It's about promoting innovation, advancing global technologies. At the heart of it, when we are talking about advancing technology for humanity, there are some key considerations. We are talking about protecting public safety, health, and well-being, and contributing to a very sustainable future. I think there was a reference to environmental aspect. I think it's very important as those are all sustainable. So with that, I would like to conclude, and I apologize for taking a minute or two and for some internet challenges at my end. But at this point of time, I will hand it over back to Heini. Thank you.
Okay, thank you, Sri. Sorry for the bad quality of the audio. I hope everybody could understand. I assume the presentation slide will be made available. So if you didn't understand everything, you should be able to take a look at the slides afterwards. With that, we covered all the, let's say, technical presentations. And the last presentation is from myself. And it's a little bit about the IoT initiative. Now, if we were on TV here, we would probably, I would probably say this program was brought to you by the IoT initiative. Now, I'm sure that not everybody has heard about the IoT initiative. So I would like to take the opportunity to give you a short presentation of what the IoT initiative is, how you can use it, and how you can contribute to it. Can you see the slides?
Yes.
Yes. Okay, thank you. Okay. So what is the IEEE IEEE initiative? Well, coming back to the question, what is IoT? I think it has been clear from the presentations from Adam and also from Dejan and also from Sri that IoT is not a single technology or a single technology layer. Instead, IoT solutions integrate a multitude of different technology domains. And similarly, the IoT initiative is not an IEEE society that focuses on a specific technology like the Communication Society focusing on communications, or the Computer Society focusing on computing, but it's really a multi-society technical group addressing all dimensions of IoT technologies, applications, and markets. So next year, there will be 12 different societies sponsoring the IoT initiative. The Communication Society is being the lead sponsor. There are major sponsors: Signal Processing, Circuit and System Society, Reliability Society, etc. And then there are smaller sponsors, including Control System, Electron Devices, etc. What is the mission of this beast, which is called IoT Initiative? Basically, the mission is to advance IoT-related education, research, development, standardization, deployment, and business. Well, that's a pretty broad focus. The focus is on the integration of the various, let me call them component technologies, to build novel solutions rather than on individual technology components. The focus is also on practical IoT solutions for vertical markets. As many of the IEEE societies are focusing on a specific technology domain, in contrast to that, the IoT initiative focuses on practical solutions rather on the advancement of a single technology domain. It brings together IEEE members from different organizations contributing to the future IoT ecosystems. And it should provide value not just for researchers and academia, but also to government, industry, and academia. Okay, so what are our main activities? Well, first of all, we do have an annual, what we call a flagship conference. It's called the IoT World Forum on the Internet of Things. The next one will be in New Orleans in end of June next year. And this conference annually has something between 500, this year we had like 800 attendees from different domains, research, industry, government. So you can find out more if you check the URL that you can see on the slides. Second big activity is the IoT magazine. So basically the IoT initiative is running the IoT magazine, which you can find under this URL, which is a forum for practitioners. Again, the focus on practitioners, not so much on researchers, to share experience, develop best practices, and establish guiding principles for the operational and business success of IoT. Thirdly, we do have an IoT technical community which publishes an IoT newsletter. The IoT technical community today maintains a website and a mailing list that meanwhile goes to more than 18,000 IoT nerds, if you want. There is a bi-monthly IoT newsletter with hot information distributed to all the members in the mailing list. You can check out the two URLs that you can see here, and you can enlist for the IoT technical community and receive the IoT newsletter at no charge. There are further activities like summits on specific IoT solution for specific verticals and markets. So like we're planning to have IoT summits for smart cities. The first one to be in Rabat in Morocco, Guadalajara in Mexico, and the third one in New York City in the US. There was an IoT summit for agriculture 2 years ago, where we're planning to have a summit on IoT for tourism this year, but that was delayed to the COVID one. We are thinking of moving it to next year or even the year after. And we've had regular summits in conjunction with the IEEE Radio and Wireless Week, specifically on radio technologies for IoT. So there's different activities going on. There are certain working groups, like a working group for smart cities, another one for education and IoT technologies, and there are further working groups under discussion. Now, how can you contribute to the IoT initiative or collaborate with it? Of course, the first step is to register to the IoT technical community to get the newsletter. There is information about the World Forum on the website under this URL. You can submit technical papers, you can submit tutorials, attend special sessions or workshops, review papers, chair session, all of these things. So please contact one of the organizers. Adam Drobot, for instance, is one of the chairs of this year's conference, but there are also others that you will find their names and contact information on the webpage. The IoT magazine, same thing. You can submit and review articles for the IoT magazine, and of course, you can propose special issues and become guest editor for special issues. And for this, you would have to contact the acting EIC, which is a Maurice Cabasa professor from Beirut. There is the IoT newsletter, as I mentioned, which publishes typically short papers and regular columns for the IoT community. If you want to contribute here, contact the EIC, which is Raffaele Giaffredo from Italy. And then working groups, again, you can contact me or others that you will find on the website. There is a link for the board, and the board has, has pictures of all the board members and URL that you can connect with these board members and get involved. So please don't be shy. If you have an idea, if you are not sure whether you have the right idea, feel free to contact us and we'll just have an open discussion and see how we can fit it in. And the IoT initiative is not the board, it's the union of all the active members in the field. So with that, I would like to thank you for your interest. As I said, you can connect to all the members, include myself, through the URL that you will see down here. And I think we have now 50 minutes left for questions and answers. Now, Srini, I'm not sure how we're going to run the question and answers.
Yeah, I think the organizers have managed something, but generally they have some questions asked in the chat.
Okay. Yeah.
And if there that will be put up, and there are a few members in the Zoom call straight away. If they have questions, they will be shooting it because they will be having the audio access. Yeah. That's the general.
Okay, I think that everybody on the Zoom connection can send a question via the chat room, and I'll try to, group them a little bit if there are too many, and the speakers will try to answer them. Okay, here's the first question coming, and I can read it so that the people on the YouTube will also see it. In IoT, innovations in technology seem to have outpaced regulatory regimes in different parts of the world. What are the market consequences of increasing lag in regulation? So maybe Srini, do you want to take that one? Sorry, Sri, not Srini.
Yeah, I can do that. So I do agree with the Satish in the fact that regulatory regime is definitely falling behind. I wouldn't say falling behind, the technology is outpacing the regulatory regime. One of the things that IEEE Standards Association is doing is we are working extremely closely with the regulators around the world, both from a technology perspective, but also from the non-functional aspects of security and privacy issues that a lot of regulators and government agencies are very concerned with. I do believe that this needs to be addressed. For example, if you look at some of the recent announcements on the 802 technologies, they have opened up a lot of spectrum on the 5 gigahertz band and also on the 6 gigahertz band to Wi-Fi to enable implementation of Wi-Fi in certain application areas like dense urban. So 6 gigahertz band is going to be opened up. I think the regulatory aspects need to catch up as more and more markets are adopting these kind of technologies. It's important that we work closely with them to ensure that the gap is closing down. At the same time, I think I will also like Adam to comment based on his experience because he has been very connected with regulators.
So let me make actually a couple of points. There is a sense in which the regulatory stuff seems to be behind where the technology is. But you have another phenomena, okay, and we have heard this at almost all of our conferences. We actually make sure that we mix in, and there are a few folks who represent what's going on in the legal and regulatory world. So of the 212 political jurisdictions in this world, over half of them have already passed regulations that affect IoT. One of my worries is that legislation often contains things that are not well thought through, that don't actually conform to what's possible. So for example, in the US, there was a bill passed that says that all IoT devices must have security built in the beginning, okay? It's a good statement. There's no idea how you could actually implement it at this point in time, okay? You will find jurisdictions like the city of San Francisco that forbade the use of devices that would capture facial images and do face analysis. Okay? You know, we can go through example after example of this, and somehow, while we don't make the decisions, it's very important for technical people to be at the table in the discussion and providing in the least informed data and understanding before that legislation happens. Okay. You know, my feeling is the legislation may be a little bit out of control at this point.
And if I can add, I'm sorry, can I add one sentence to that? I mean, in Europe specifically, there's very strict
GDPR.
GDPR, yes. There is a very strict data privacy protection regulation, and it's absolutely unclear how you can run any IoT application with that regulation in place. So the question is certainly absolutely valid, and Europe will have to come forward with let's say, a more practical solution. I'm a big fan of data privacy. I'm not a big fan of GDPR in the way it is written. Okay.
I would just like to add that, Satish, great question, but I think it's the natural cause of events. You want technology to develop unimpeded, and the standards and regulations come only later. Because as Adam was pointing out, if you put in regulations that hamper the development, then we're in the worst position. So I think there's still a lot to be developed before we can even standardize, but you can start standardizing and certainly start regulating, but they have to lag technology.
Yeah. You know, one thing is there really has to be one regime which says you can experiment with things. It's another thing to say you can do complete deployment of things without that experimentation actually having reached the level where you understand what you're doing.
Exactly.
Yeah, I think it is natural, according to me, that we from the academics will not have any boundaries, and that's why the technology will always outpace the regulatory aspects. I think that's the usual natural way of things evolving. So only thing is we have to be worried only if the technology is really far ahead of the regulations.
We have to be responsible.
Yeah, that's the only thing I want to say.
Okay, let's move on to the next question, and I'll read it for everybody to hear. So many devices getting connected through IoT. Most of them are wireless connected. Are there any studies on biological effects of so much devices transmitting? I guess,
Yeah.
Venka, you're wireless.
By the way, 92% of the connections we have are not wireless. They're fixed.
Yeah. Actually, probably this one and the next one also I might touch upon these two questions. Something that we really see is that the IoT devices are not going to really cause so much of issues with respect to radio emission. And of course, there were lots of studies that have not proved any adverse effect unless otherwise you are very near to the emitting bodies, very high power antennas or things like that. So, but for normal people with few of the devices in their homes or even in factories, I don't think it will affect. The other thing is also that the data that you are going to transmit using these IoT devices is so small that you are not going to keep these devices continuously on. So if that is the case, then you may have to really come up with a different communication technology altogether. So I don't really see an issue at this point of time because none of the studies have proved this. Of course, city of Hague has been in news for some time. they were showing.
Does not cause COVID. Okay.
And of course, nonetheless, to say that that was fake anyway. But Hague was very popular about a year back. Yeah.
Rainer, it's worthwhile to add two things, okay? The first one is that there have been 3 very large studies, actually done more by the medical community, on biological effects of non-ionizing radiation, okay? Which show that at the frequencies below 6 gigahertz, really, other than thermal effects, there is no impact. Once you go to 60 gigahertz, the higher frequencies, okay, thermal effects are important, and there are real thresholds for those. Okay? And right now, that's the part of the spectrum that we're just starting to experiment with.
So I have one small comment here.
You want to
make a comment here? Yeah. So this is also very interesting. You know, we see a lot of times this question comes up. IEEE also develops standards which are actually specifying the limits for specific absorption rates, SARs, and how much a device can emit, how much tolerant should a device be, and that is going to be very, very important as a question on regulatory. When people are having import-export policy restrictions, they will actually make sure that your devices are complying to these standards and there is a certification that happens. So yes, I think there are studies that are happening to make sure that whatever we understand is actually true and it can be tested in a practical way through standards. How practical IoT is as of now? I think we are already seeing a lot of implementations. For example, in advanced manufacturing, industrial IoT, this is really happening. And you and I today use IoT when we book a car or Uber or online movies and everything. So if people think that IoT is not here, it has been around for maybe about 5-10 years, both in the consumer space as well as on the industrial space. Thank you.
Thank you, Sri. And I think we have time for another question. The next one would be Srini. You want to read your question?
It's on the with respect to the energy harvesting.
No. We covered that one. Wait a minute. Energy.
Yeah, that is a practical IoT.
Yeah.
What
part of IoT is practical IoT right now?
Right.
And
Yes.
what part of it is taking care of the energy harvesting part? I think.
Yeah, I want to take just 1 minute. Probably this may be very interesting for people.
Throughout the aircraft body to connect numerous sensors and actuators. These cables add up to the overall aircraft weight and increase the fuel consumption and complexity in deployment. Examples include reading lights, attendant call buttons, and display systems that require maintenance and replacements when they go defective. To this end, we propose a cost-effective, zero-energy-based, miniaturized, wireless, and batteryless IoT switch, which is very easy to deploy for various applications. The existing switches, such as the call crew button and reading light, can be easily replaced by our wireless switch. A single press is sufficient to indicate passenger assistance requirement on crew display units. Even hundreds of our switches can function simultaneously with high reliability. The switch can also be employed in passenger safety systems, such as seatbelt monitoring, without disturbing the passengers during takeoff, landing, or when there's turbulence. The switch embedded in seatbelts indicate when it is latched and unfastened. With this, crew members can easily identify only these passengers, avoiding seatbelt inspection of all the passengers, thus saving time. Even the position of...
Okay, I think I will stop sharing. You must have already got some hints about what I'm trying to say here. So things are already there, and this was the project that we did, and we competed in Airbus Challenge last year. So we were lucky enough to beat like 200
passenger seats can be monitored in the same way.
Around 300 teams, and so there is a lot of interest already, and there is a small startup coming up from TU Delft. So it is almost there now. It depends on how exactly we can utilize the energy harvesting possibilities. So something that you can definitely see here is the context is because of an action. and because of an action you get the energy, and because of the energy you learn about the context. So it is a complete loop which we can really utilize. So my take is that it's in a year or two there will be more and more energy harvesting IoT systems that's going to get embedded into various places. Yeah.
VP, let me add to that, because I've seen 3 or 4 fairly interesting things. So first of all, rectennas have been around for a long time. You now find rectennas that work in the infrared, great energy harvesters. Actually, surprisingly, there are billions of those already out there, okay? That's one. The second one is, if you have a TV, you probably have a remote. It uses batteries. The use of batteries is not exactly great for the environment.
Yeah.
You will now see prototypes. I think they're flooding the market of remote control devices, which all scavenge power from Wi-Fi sets that are close by. Okay, replacing the need for hundreds of millions of batteries a year, essentially. Okay. So lots of practical things in that area, and I'd say a lot more coming.
Thank you, Adam. And I don't know whether we have any other comments, but we run out of questions and we run out of time. So that's a good coincidence. So I would like to thank the speakers for their very interesting presentations, despite the tight timing that we had. I'd like to thank Srini and his team for providing the IoT initiative the opportunity to talk a little bit about the things that we're doing. And I would like to encourage everybody on YouTube or on the Zoom connection here, feel free to contact us and we'll be happy to give you a place where you can contribute. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Good night, and get involved, please. We want you to be part of this.
Thank you. Before you leave, there is one little step that we would like to request you to stay on for 1 minute more. Now, we can't obviously give you a memento as we would have done had you been present here. So we have for you virtual mementos, which you can see on the screen, but perhaps not download. So can I request the organizers to please show first, Hendrik Rodgen.
Yeah.
So this is the virtual memento. Thank you very much for sharing. Next, we have Venkatesh Prasad.
Thank you.
Thank you very much, Venkatesh.
Thank you.
Dejan, I think he might have left, but Dejan Milojic. Thank you, Dejan. Adam Drobot. Thank you, Adam. And Srikant Chandrasekharan. Thank you.
Sri, yes.
Sorry.
Will you be able to send us a copy of those slides? Those are nice.
We'll be able to send you the copy of this.
Thank you.
Thank you.
Thank you very much.
Yeah.
Thanks.
Are you collecting the view graph somewhere? What would you like us?
Yeah, we would like the presentation so that we can distribute our.
To whom should we send it?
We will send you an email for that.
Okay, good.
Okay, thank you.
Okay.
Thank you.
Thank you. And goodbye.
Bye-bye.
Good night. Good night.
Good
Bye.
night.
Have a great,
It's not
have a
quite
great
time to
weekend,
sleep.
all of you.
Not for
Stay
you.
safe. Bye.
Yeah. So back to you, Dina, for the next part of the event.
Thank you once again to all of you for providing us with a cross-dimensional perspective on such a vast topic that is Internet of Things. We are deeply indebted to you for taking a significant portion of your time amidst your very busy schedule to join us here. And with this, we are at the end of a brilliant session on the Internet of Things. The Internet of Things is making the fabric of the world around us more smarter and more responsive, merging the digital and physical universes. Thank you once again to all the dignitaries who have graced this occasion with their esteemed presence to engage and edify us for the course of this session. It has been an absolute honor and privilege to have you here. With this, our special session on IoT comes to an end. Handing over to Fatima to take the floor for the valedictory session. Thank you, everyone.
Thank you, Dina. Honorable dignitaries, participants, and fellow members of the IEEE community, a very good evening to one and all. Welcome to the valedictory session of IEEE RAICS 2020, which is an international conference organized by the IEEE Kerala Section on recent advancements in intelligent computational systems. This is the first time that we have hosted it in a completely virtual mode, and I feel privileged to have been a part of this event, which I believe has inspired many to use technology to contribute in the advancement of humanity. I take this opportunity to invite the chief guest of this session, Dr. K.R. Suresh Nair, who is the chair-elect of IEEE India Council, to deliver the valedictory address. Over to you, sir.
Okay. Respected dignitaries, participants, my fellow IEEE colleagues, very good evening, very good late evening. IEEE RAICS 2020, the 5th edition of the International Conference on Recent Advances in Intelligent Computational Systems, organized by IEEE Kerala Section, is now coming to a successful end. This year's theme, namely computational technologies for a healthy humankind, is very well aligned to IEEE's tagline of advancing technology for humanity. The pandemic has not stalled the enthusiasm and spirit of organizers as well as participants, and everyone has accepted the new normal. Even though every time when we present anything virtually, we need to ask the listeners whether I am audible and are you able to see the screen. The data bandwidth varies, and many times we hear the talk as sweet song. So a lot of scope for technology improvement on that ground also. In fact, going back to traditional physical conference may be an issue now after experiencing the comfort and convenience of virtuality. Societies will die if they don't continue to innovate. Technologies are neither good nor evil on their own, but in the right hands can become powerful benefits to the society. We need bright and ethical people to understand our best and most powerful technologies to ensure they are all used for good. The last few decades, technology has progressed at a staggering rate. Smartphones, internet, cloud computing, and hundreds of other inventions are changing every facet of our lives. Communication, business, government, travel, even fundraising, and even agriculture have been affected. But how about our brains? Is all this new technology changing us on the inside? The evidence suggests that reliance on the internet and mobile technology is shortening our attention spans. Our recent study found that our average attention span has decreased by 4 seconds, down from 12 to 8, which is shorter than that of a goldfish. Though there are very many parallel sessions, I'm very sure RAICS 2020 has covered most of the similar aspects. There were exceptional keynote speakers, and I did attend some of them, including that by Professor Ashokan on autonomous robotics, Dr. Brijan Singh on rugged power systems as well. We just concluded exemplary session on IOT. The 8 tracks on signal processing to energy systems to IoT all covered almost the entire spectrum of the theme. My great appreciations to every volunteer associated with this conference, and when anything is done by IEEE Kerala Section, it is done royally. Specifically appreciate the efforts of Mr. Sadish Babu, Chair, Professor Bijuna, Professor Jisha, Mr. Nandan, Dr. Jason Matthew, Dr. Suresh, Mr. Shankar, Mr. Neeraj, and Mr. Anup Matthew for all the track chairs. Thank you for inviting me to this valedictory function. Thank you very much.
Thank you, sir, for those wonderful words. We at IEEE Kerala Section would now like to present you with a memento as a token of gratitude.
Thank you. Thank you very much.
Thank you, sir. I now call upon Professor Nandan S., who is the Finance Chair of IEEE RAICS 2020 and also the Student Activities Chair of IEEE Kerala Section, to deliver the vote of thanks. Over to you, sir.
Okay, thank you. Good evening all, good day all. respected dignitaries present in this meeting, my dear fellow IEEE volunteers, organizing committee members of RAICS 2020, participants in this meeting, and those who are watching our YouTube live session, our active technical team, and my dear friends, a warm good day to all of you. So we have thus successfully come to the conclusion of the 5th edition of the IEEE International Conference on Recent Advances in Intelligent Computational Systems, RAICS 2020, the biennial flagship conference of IEEE Kerala Section. So due to this current pandemic situations, we have decided to conduct this edition of RAICS virtually, and we are very proud to announce that all our sessions went well with excellent support from the technical team, from the speakers, and obviously the participants. So the theme of the conference was, is computational technologies for a healthy humankind with, 8 different tracks, papers from 8 different tracks and diversified fields. So I feel so happy to announce that this 5th edition of RAICS is now successfully coming to an end here. So let me directly come to the duty which is assigned upon me today to formally deliver the word of thanks. So let me start with, the chief guest of today's session, Dr. K. Suresh Nair, Chair-elect IEEE India Council, for spending your valuable time with us today during this valedictory function of RAICS 2020. Thank you so much, sir, for being with us. Thank you so much. On behalf of the organizing committee, I would like to thank the chief guest of our inaugural session, Dr. Michael R. Leitner, the past president of IEEE, all the keynote speakers, Dr. Brijen Singh, then Dr. Ashokan, Dr. Shiju SS, then Dr. Gerard Joseph, Paras Lumba, J.D. Bansal, the whole team of speakers lined up for our conference. A sincere, very sincere thanks to all the speakers mentioned here. A very sincere, heartfelt thanks to the speakers of today's IoT session as well, Heinrich Studgen, then Venkatesh Prasad, Dejan, Adam Drobot, and Srikanth Chandrasekharan for sharing your valuable knowledge with the participants. It was really an amazing session. Thank you again, all of us. A very big thanks to all the track chairs. They really need a very, very special thanks from our side on behalf of organizing committee. Why? Because the time and effort they spend for organizing these papers, for reviewing these papers, it's something beyond words. So a very special thanks to Dr. M.V. Rajesh of MEC, Dr. Sugesh Kumar, Dr. Ashraf S, Dr. Abhilash T. Vijayan of RIT, Dr. Rijil Ramachand of NIT Calicut, Mr. Srinivas R, Dr. Jason Matthew, Mr. Jay Krishnan MC, Dr. Jayashree, Mrs. Anjana P. Das, Dr. Kurian Isaac, Dr. Biju K of College of Engineering Munnar, Dr. Deepthi Shashidharan, Dr. Meenakshi, Dr. Sabina Bibi of TKM, and Dr. Shaji Mohan. And thank you so much. It's because of your timely response and efforts we could successfully complete the review process as well as the presentations. So thank you so much, all track chairs, for your valuable support and the effort they have put in to make this conference a big success. Our sincere thanks to all the reviewers of this conference, and our reviewers actually really helped a lot to maintain the quality of papers, thereby ensuring the quality of the conference. So a big thanks to all the reviewers for timely completing the review process. Thanks a lot. And I would also like to thank the team behind our registration team, Yabdesk AOT Technologies, Mr. Irshad and his team, for the support they have given to successfully complete the registrations. A very, very sincere thanks to all the authors, co-authors, and registered participants. Hope you had a wonderful experience and a smooth paper submission, a registration, and presentation experience. Thank you so much all. It is because of your presence, it is because of your support, we could record all the videos prior to these presentations, and we had a very smooth presentations in all tracks, in all sessions. Big thanks to all the participants. And a big thanks to all the office bearers of the society chapters who partnered with us, especially Computer Society, EMBS, Robotics and Automation Society, Power Energy Society, IEPLS Joint Chapter, Signal Processing Society, ComSoc, Section Site and SSIT groups for the support you have given towards arranging, managing our keynote sessions and speakers. Thanks a lot. And I cannot stop this without mentioning the EXICO members of IEEE Kerala section. Obviously, the support they have given in all the activities are something beyond words, especially section chair, Sharda madam, all our life senior members, members and young professionals. And thanks for your support and guidance to bring this conference to such a successful moment. Now, I need to, no need for a special thanks, but they really deserve it. No, the steering committee of RAICS 2020. So it's very, very special thanks to Mr. Satish Babu, who is a conference chair, for your valuable guidance and support throughout, right from starting till this moment. And thank you so much, sir, for your support, for guiding us to bring this conference to a great success. And very, very special thanks to the technical program committee. They worked a lot, 24/7, arranging the sessions, papers, emails, replying to emails, everything right from starting. That the kind of effort Dr. Bijuna ma'am and Dr. Jisha ma'am they spend is something beyond words. The kind of efforts they have put in. So a lot of sleepless nights, meetings and all. Thank you so much for your support, for your efforts that you have put in to make this a grand success. And thanks a lot to Dr. Suresh K, who is a publication committee chair, and Dr. Jason Matthew, who managed publications as well as our conference paper submission system, properly communicating with our authors, and there were no complaints or anything raised from their side. They managed it very well. Thank you so much. And very, very special thanks to Dr. Bobby Phillip for overall managing the conference. He's a conference convener for overall managing all the activities of the conference. And a special thanks to Mr. Shankar J, who is the publicity chair and who did very well to get maximum reach publicity to our conference among the professional community. And a web team, Mr. Neeraj Aip and Mr. Anup Matthew, and we and Neeraj had a lot of late night meetings and all to successfully make our website a wonderful one. And thanks Neeraj for your efforts apart your busy schedule and to make our efforts to a beautiful moment that we are right now here. So thank you so much all the core committee members. And now the core team who worked 24/7 to make this event a huge success for the past so many years. The technical team led by who is our ECC, part of our ECC team, Mr. Alan Matthew and Jacob Thomas, and the very vibrant, most vibrant student leadership team who successfully worked behind this conference, Mr. Ruben Matthew, Eldo Babu, Cliffin Cletus, George Govindaraman, Agas Nair, Devika, Anandajit, Fatima Nasreen, Arjun Sunil Kumar, Amit Tony Joseph, Dina, Shan, Joel John, our designers, and Ananjit and Gaius G. De Cruz. All the 16 people plus 2 leaders, Alan and Jacob, really worked well, managed all the sessions without any delay, without any confusions. They wonderfully managed all the technical sessions in a very beautiful way. So a very big thanks to all these, vibrant youngsters who worked behind successfully organizing this conference these days. And thanks a lot once again to all those who associated with us, all those who supported us, all those who worked with us, apart your busy schedules and all. Thank you so much again from bottom of our heart. A very sincere thanks for your support. Thank you. Thanks a lot.
Thank you, sir. Thank you for that wonderful address. Now, with that, we've almost come to the end of IEEE RAICS 2020, and I would like to invite Dr. Satish Babu, the conference chair, to close the session. Over to you, sir.
Thank you very much. I know it's very late and we're tired, so this will just take a minute. First of all, on behalf of all of us, I'd like to congratulate and thank all my colleagues on the RAICS organizing team. When we started out, we had a number of unknowns, particularly with regard to the virtual aspect. But with consistent hard work and enthusiastic teamwork, we have actually conquered all of them. In the process, we believe that we have built capacity within the Kerala section to handle virtual conferences, even if they are much bigger than this. And the entire credit for this goes to the team, which Nandan has mentioned all the names there. And I'd also like to thank the Kerala Section chairs, society chairs, the Kerala Section leaders, and the whole community for their consistent support to RAICS 2020. With this, I declare RAICS 2020 closed, and we look forward to the 6th edition of RAICS in 2022. Thank you and good night.
Thank you, sir. Before we part, it would be great if we could have a group photo session.
Mm-hmm.
Everybody, kindly turn on your videos. Eldo, I request Eldo to take a picture.
Shankar sir?
Yeah, Shankar sir.
Shankar sir, am I audible? Shankar sir, am I audible?
Yes, actually, I'm traveling. I hope I am audible.
Yes, sir, you are audible.
So we have a few more person too. Sharda ma'am, JK sir. Actually, I'm traveling in train. Can you all hear me?
Yes, sir, we can hear you.
Actually, I feel that all are pausing or it's pretty stuck. I'm not sure. So, okay, Vijay sir, Srini sir, Jayasri ma'am, Clifton, Aishwarya, Utimalu, miss. I can't see you.
Shankar sir, I think your net is low. Network is low. So you are
Yes, I believe my net is slow. Okay.
Oh, okay. Eldo, you can take the picture.
Yeah, okay, then I will take the pictures.
Eldo, 49 in one slide, yeah?
No, I can't get 49 people in one pic. My computer won't support that one.
Okay, yeah.
I can get 25.
Let me check once again.
You can go to settings and you can do that.
And also, the function is supported for the ISO laptops only. So, sorry for that. Anyway, I will try to include in 2 gallery views, all of you people. So, in the count of 1, 2, and 3, all of you say IEEE. 1, 2, 3, IEEE. 1 second. One second. Yeah, it's good. Thank you, everyone.
Okay, thank you. Bye-bye.
Bye.
Thank you, sir. Thank you, Eldo.
Thank you, everyone. Wonderful event.
Yes, great, RAICS. It has been very great.
Listen, you can give the host rights to Alan Charan. Hello.
Hello, actually there's 2 IEEE Kerala Section, so
I had taken that right.
Yeah. Okay.